Capacitance was the last concept that we had to study, understand, bring our awareness to, bring our attention to capacitance in the different fields of physics. But before we do that, we should probably revise a little bit of what we have learned so far. So let's look back at the concept of power. Just as a revision, now we talked about power as a concept, and power means rate of work, right? Energy divided by time. So the unit of power, the watts, means joules per seconds. So this is power as a concept. Now, we have seen power in the different fields of physics. 1, 2, 3. 1, 2, 3, 4, 5. Okay. So we've talked about the element earth, mechanics. We talked about the element air, gases, water, liquids, fluids, fire, heat, and space, electromagnetism, and everything else, no? Everything else. Space is the biggest mystery. So in mechanics, we thought that power had two factors, right? There are always two factors in power. Let me write with a different color. Two factors in color. Two factors. We said in mechanics that energy meant mass times gravitational potential, or in other words, force times distance, right? So it's force times distance divided by time, because it's rate of work. And this is velocity, right? So the power in mechanics is the multiplication of force and velocity. And we could see that in a gear system. Suppose that you have a bicycle. So this is your paddling system. This is the back wheel here. This is the back wheel, right? So, and this is the chain. So if the number of cogwheels here is 10 and the number of cogwheels here is 100, the ratio is 1 in 10, right? So that means that I can play with the factors of power. I can change the gears in my bicycle so that for every energy, every work that I do here in pedaling, I can transform the power, work over time, I can transform that into higher velocity and therefore less force. That, if I use red, so this should be for red. Higher velocity and red force, because every one turn I do here, it's 10 turns of the wheel. And the other case is this one. I make 10 turns here and it's only one turn in the wind. So here I am reducing velocity and gaining force. This is what we call the first gear here, the first gear, right? And the second gear is this one here, or higher gear, because you're gaining velocity. But you always lose force. You can't gain power. Power is the amount of energy that a system uses per time. You can't gain power. In the gases, if you have a certain volume of gas at a certain pressure, and that is flowing over time, this is the flow of gas. So the flow times the difference of pressure is the power of a gas. And this has to do for both, for fluids, it's fluid dynamics, it's very complex physics, and this is explained using Bernoulli's law and principle. So we're not going to deal with that, but mainly the energy in any fluid is the product of the pressure times the flow. And the flow is the amount of volume in cubic meters per unit time. Power. concept of power could explain, for instance, the concept of power in fluids could explain why a plane flies. I'm going to show it with green. Suppose this is the airfoil of a plane, and we have fluids, like could be air. Air is coming like this. Okay, let's put it green. The air is coming like this. And it goes down. And here it continues straight, right? So imagine two molecules of air that are here, molecule A and molecule B. They have to end up together once the plane passes through. This is the size view of the wing of a plane, an airfoil. The air bends to allow, it's an elastic medium, it bends to allow the plane to pass by. And in that process, the molecules of air at the top of the plane must gain velocity because they travel more distance at the same time, right? But if they gain velocity, they lose pressure. So that is why here there is more pressure. And that explains that force that appears as an upthrust. The force that appears here as an upthrust, this force here, boom. The force has to do with this difference of pressure between this side of the foil and this side of the foil. There is more air pressure here because there is less velocity, because the molecules go through the shortest way. This concept of wind power could understand the airfoils as transformers of heat. And transformers of electricity, we saw voltage and current in the primary has to be equal to voltage and current in the secondary. In a transformer, what you do is you step up or you step down transformers. If you increase voltage, you sacrifice current. If you step down, you can sacrifice voltage to increase current. So an electric transformer changes these two factors. One that represents potential, voltage, and the other one represents flow, current. You can increase voltage, for instance, if you're going to send energy far away, you can increase voltage and sacrifice current. Okay, so that is a revision on power, on some of the concepts, but applied into systems that transform power. We're going to look at a new concept now, the concept of capacitance. Capacitance. It is what we observe over the potential difference, the variable over the potential difference. That would be the law, the formula. What does it mean? It means the ability to store and release whatever it stores and releases. That. What is that? That could be the ability to store charge and increase voltage, and that is called the electrical capacitor. That is what a tank does in electricity. A capacitor stores charges. That's, for example, for electricity. In the case of mechanics, I'm gonna go into this web of concepts. Then I am going to look at the concept of capacitance here. In space, we saw that capacitance was charge per unit volume, the ability to absorb charge and increase voltage. This is what an electrical capacitor does. It absorbs charge and stores it. And in the process of absorbing charge, it is increasing voltage, right? A lung is a device. All the lungs, what they do is or a cylinder that has gas inside, something that stores a high pressure of gas. This is a very high pressure of gas. So a huge volume of air could be trapped into a tank. This is what the lungs do in a body-mind system. The lungs absorb, retain, and release the air that we inhale. So the lungs are the air capacitors. The concept of, or the ability to absorb, retain, and release energy, and in that process increasing temperature, is called specific heat capacitance. It is the amount of energy that we need to absorb per unit mass to increase 1 degree temperature. Any substance. High specific heat capacity, for instance water, means that the water takes a lot of time to store the energy from the sun and then a lot of time to release it back. It's a greenhouse gas, and it is the capacitor for heat. The oceans are the absorbers of heat. Waters are not good for capacitors. Water have very low compressibility, so low capacitance. Capacitance is the compressibility of a gas. Water has very low capacitance. That means that if you put pressure into water, it does not change its volume. It's very hard to compress. And in spring, a capacitor is, on Earth, a capacitor is a spring. The ability to absorb a certain load and increase a certain distance, this has been called elasticity, the Hooke's law. The capacitance in mechanics could be, for an example of a capacitor in mechanics could be a spring. So capacitance is a concept that has a general definition and then specific words, specific units, but the same law in all the systems. And we saw power already. So what's next? Just take a few minutes and write on a piece of paper these lines with two concepts: power, capacitance. And then what is important, the law and the definition and the unit, and then in the different systems, mechanics, hydraulics, gases, heat, electromagnetism, electricity. Right? What equations, what formulas, what concepts must we put here? This is matrix number 3, capacitance and power.